Picture this: a caveman waddling through the savannah, gut jiggling with every step, sweating through his mammoth hide loincloth, complaining that his pants don't fit anymore. Sounds ridiculous, right? We've all got this mental image of ancient humans as lean, chiseled hunting machines who could sprint down an antelope and then pose for a Renaissance sculpture afterward. But here's the question that's going to break your brain a little. Could an actual prehistoric human have been fat? Like, genuinely, doctor's office lecture, "Can't see your own feet, obese"? Stick around because the answer is weirder, funnier, and more unsettling than you'd expect. Let's start with the obvious objection, because I know you're already typing it in the comments. Obviously not. They were starving all the time. They had to run from lions. There was no McDonald's. Fair enough. That's the instinctive answer, and it's not wrong exactly. But not wrong and the whole truth are very different things, and evolution loves nothing more than proving humans wrong about our own bodies. So let's set the scene. We're talking roughly 300,000 years ago, give or take, when anatomically modern humans show up on the scene. No agriculture, no grocery stores, no stress eating a family bag of chips while doom scrolling at midnight. Just small bands of people wandering around, eating whatever they could hunt, gather, scavenge, or occasionally steal from a hyena that made the mistake of leaving its kill unattended for 5 minutes. This is what scientists call the environment of evolutionary adaptedness, which is a fancy way of saying the world our bodies were actually built for, as opposed to the world we live in now, which our bodies are absolutely, catastrophically not built for. In that ancient world, calories were not a threat. Calories were the whole game. Every single calorie you could get into your body was a tiny victory against the very real possibility of starving to death. There was no such thing as cutting carbs. There was only, please, for the love of everything, let me find some carbs. Food was inconsistent, seasonal, and often required an enormous amount of effort just to acquire. You didn't get a bag of berries by clicking a button. You got a bag of berries by walking for hours, getting scratched by thorns, fighting off bugs, and hoping a bear hadn't found the bush first and eaten the evidence. Given that reality, you'd think obesity would be biologically impossible, and for the vast, vast majority of ancient humans, it basically was. But basically impossible is doing a lot of heavy lifting in that sentence, and that's exactly the crack we're going to pry open today. Here's the first twist. Your body was never designed to avoid getting fat. It was designed to avoid getting thin. Let that sink in for a second because it's the key that unlocks this entire video. Evolution doesn't really care if you're a little chubby. A little chubby doesn't kill you. But starving absolutely kills you. And it kills your ability to reproduce, which, from evolution's cold and slightly terrifying perspective, is the only stat that actually matters. So your body evolved an obsessive, borderline paranoid relationship with fat storage. Every spare calorie that didn't need to be burned immediately got shoved into fat cells like a squirrel cramming acorns into a hole, except the hole is your love handles and the squirrel is your pancreas, running on pure panic. This tendency has a name, and it's one of the most famous ideas in evolutionary medicine, the thrifty gene hypothesis. The idea, first proposed back in the 1960s by geneticist James Neal, goes something like this. Ancient humans experienced regular cycles of feast and famine. Sometimes you'd stumble onto a beehive dripping with honey, or take down a large animal that fed the whole group for days. Other times, the hunt would fail for a week straight, and everyone would be eating bark soup and quiet regret. In that kind of world, the humans who survived best weren't the ones who burned calories efficiently. They were the ones who hoarded calories aggressively, packing on fat during the good times so they had a buffer to survive the bad times. Over tens of thousands of years, this hoarding instinct got baked directly into our DNA. So here's the uncomfortable part. You, sitting there right now, watching this video, are the genetic descendant of the ancient humans who were best at getting fat. Not the leanest, most efficient calorie burners, the best fat storers. Your body is, biologically speaking, an evolutionary trophy for gluttony. Congratulations, I guess. Now, obviously, having a body that's really good at storing fat doesn't automatically mean ancient humans were fat. You need two ingredients for obesity: A body capable of storing fat efficiently, and an environment that actually gives you the surplus calories to store. For most of prehistory, ingredient number 2 was almost never available in large enough quantities, for long enough stretches, for that thrifty biology to really cause a problem. It's like owning a Ferrari but living on a street with a 5-mile-an-hour speed bump every 10 feet. The capability is there. The opportunity mostly isn't. Mostly. Not never. And that word mostly is hiding some genuinely wild stuff. Before we get to the evidence, let's take a quick detour through the animal kingdom because humans are far from the only creatures with this weird fat hoarding obsession, and looking at our relatives actually makes the human case make a lot more sense. Bears famously gorge themselves before hibernation, packing on enormous fat reserves in a matter of weeks because their environment gives them a short, brutal window of abundance followed by months of nothing. Certain migratory birds do something similar, nearly doubling their body weight before a long flight because burning through fat reserves mid-ocean is a much better plan than starving to death somewhere over open water. Even our closest primate relatives, chimpanzees, show clear evidence of fat storage during fruiting seasons when food is abundant, only to burn through it during leaner months. None of these animals are obese in any clinical sense, but they all share the same underlying logic humans do. When the food is there, take it, store it, and worry about the consequences later, because later, you is a problem for later you to solve. Humans just happen to be unusually good at this game, for a very specific reason that a lot of people don't think about. Our brains. The human brain is an absurdly expensive organ to run. It makes up about 2% of your body weight but burns something like 20% of your resting energy all day, every day, whether you're solving calculus problems or just staring blankly at a wall. Some researchers argue that our unusually large brains and our unusually aggressive fat storage tendencies actually evolved together, hand in hand. A brain that expensive needs a reliable energy buffer, and body fat is basically a walking battery pack. Human babies, for example, are born with a dramatically higher percentage of body fat than the babies of almost any other primate, precisely because that fat is thought to help buffer the enormous energy demands of a rapidly growing infant brain. So, in a very real sense, the same biological machinery that gave us the ability to write poetry, build rockets, and argue about football on the internet is deeply, intimately tied to the same machinery that gives us muffin tops. Evolution's sense of irony really is unmatched. Okay, back to ancient humans specifically, and the actual evidence that some of them really did carry serious extra weight. Let's think about what mostly lean is hiding by looking at different environments ancient humans actually lived in. We tend to picture cavemen as one uniform group, but human societies before agriculture were incredibly diverse, spread across wildly different environments, from freezing tundra to lush river valleys to coastlines absolutely stuffed with seafood. And in a small number of these environments, food wasn't scarce at all. It was abundant, reliable, and almost relentless. Take coastal and riverine communities with access to massive, predictable food sources like salmon runs or shellfish beds. If you're a hunter-gatherer group living next to a river that fills up with thousands of fish every single year like clockwork, you don't have the same feast or famine roller coaster as a group chasing unpredictable herds across open plains. You have something closer to a calorie subscription service. Archaeological evidence from certain Pacific Northwest coastal populations, for example, suggests some groups had access to food surpluses so reliable that they developed semi-permanent settlements, stored food for winter in enormous quantities, and built complex social hierarchies, all things we usually associate with agricultural societies, not hunter-gatherers. Similarly, groups living near massive shellfish beds along ancient coastlines could essentially walk down to the shore and collect a guaranteed, low-effort meal any day the tide allowed it. No risky hunting required, no unpredictable herd migrations to track for weeks. When food gets that reliable, that consistent, and that abundant, the conditions for at least some individuals putting on serious extra weight start to become biologically plausible, not just theoretically possible. And speaking of evidence, let's get to the good stuff, the actual physical proof that ancient humans weren't all lean and sculpted. I want you to think about one of the oldest known pieces of art created by human hands, the so-called Venus figurines. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. These little carved statuettes, some dating back over 25,000 years, show up across Europe from what is now France all the way to Russia, and a huge number of them share a very specific, very consistent set of features. Wide hips, large breasts, a pronounced rounded belly, full thighs. These are not lean athletic figures. These are, by any modern standard, figures depicting a fuller-bodied woman. Now, archaeologists have argued for decades about exactly what these figurines meant. Fertility symbols, depictions of an idealized body type, self-portraits made by women looking down at their own bodies from above, which would naturally exaggerate the belly and thighs relative to a distant viewing angle. Nobody knows for certain, and I'm not going to pretend there's a single settled answer because there genuinely isn't, and any video that tells you otherwise is lying to you. But here's the thing that matters for us. Whatever the symbolic meaning, an ancient artist had to have observed a body type like this to carve it with such consistency across thousands of years and thousands of miles. You don't accidentally invent a rounded belly and full thighs out of thin air, tens of thousands of years before anyone had ever seen a magazine cover or a fashion advertisement. Somewhere, at some point, ancient humans were looking at bodies carrying real, visible fat and finding that image significant enough to immortalize in stone, ivory, and clay. That alone should be enough to make you pause and reconsider the "every single caveman was a shredded action hero" image you've been carrying around in your head since childhood. But let's push further, because figurines are interesting, but they're not exactly a medical chart. What does the skeletal evidence say? This is where paleopathology comes in, the study of ancient disease and health through the examination of old bones. And skeletons, it turns out, are surprisingly chatty if you know how to listen to them. Obesity itself doesn't leave a direct fingerprint on bone the way, say, a broken leg does. Bones don't come with a little tag attached that says, "This person had a body mass index of 34. But obesity's effects on the body absolutely do show up, especially in joints. Excess body weight puts chronic, repetitive stress on weight-bearing joints, particularly the knees, hips, and lower spine, leading to a condition called osteoarthritis, where the cartilage wears down and the bone itself develops telltale changes like bony spurs and roughened joint surfaces. Researchers examining ancient skeletal remains have, in certain cases, identified patterns of joint degeneration consistent with excess weight-bearing stress in individuals who otherwise appear to have lived long enough and eaten well enough to develop these kinds of chronic conditions. This is rare, and it's not the norm across the fossil record by any stretch. But rare isn't the same as non-existent, and that distinction is basically the entire point of this video. There's also something worth mentioning about status and privilege, because obesity throughout most of human history, right up until surprisingly recently, wasn't a sign of poverty. It was a sign of wealth. Think about it from a purely logical standpoint. If food is scarce and hard to get for most people, who is the one person in the group most likely to have consistent, abundant access to it? The leader, the chief, the person other people are bringing food to as tribute, as gift, as political currency. Across many ancient and pre-modern societies, all the way from early chiefdoms to later empires, a larger body was frequently a walking billboard. That said, I have never once missed a meal in my life, and neither will I ever. Being visibly well-fed was proof you had made it. It's only in the last 100 years or so, once cheap, calorie-dense food became available to literally everyone, that this flipped completely. And leanness itself became the new status symbol. Ironically, because now the wealthy are often the ones with the time and resources to exercise and eat expensive, low-calorie kale salads, while everyone else survives on inexpensive, calorie-dense fast food. Evolution didn't see this plot twist coming, and honestly, neither did we. It's also worth looking at what modern hunter-gatherer populations can tell us. since we obviously can't put an ancient human on a scale, but we can study people living lifestyles that are at least somewhat comparable today. Groups like the Hadza in Tanzania, who still practice a foraging lifestyle, tend to show remarkably low rates of obesity and related conditions like heart disease, even into old age. This has often been used as supporting evidence for the cavemen were universally lean theory. But here's the catch that a lot of pop science explainers conveniently leave out. Modern hunter-gatherer groups are not a perfect stand-in for every single ancient human population that ever existed. They represent a narrow, specific slice of environments and lifestyles that happen to have survived into the modern era, largely because they occupy marginal land that agricultural societies didn't want. The population living next to an endless salmon run 12,000 years ago, and the population currently studied hunting on the semi-arid savanna today are not necessarily living the same version of the hunter-gatherer experience at all. Using one to perfectly represent the other is a bit like assuming everyone in the world eats the exact same diet because you looked at one restaurant menu. So if we zoom all the way back out, here's the honest, nuanced answer to the question in the title. Could ancient humans become obese? For the overwhelming majority of prehistoric humans, living the classic hunter-gatherer lifestyle in an unpredictable feast or famine environment, full-blown obesity was extremely unlikely, simply because the caloric surplus required to get there almost never existed for long enough. Your average Paleolithic human was almost certainly lean, not because their biology rejected fat, but because their environment rarely gave them the chance to store much of it. But under the right conditions, abundant, reliable food sources, elevated social status, certain leadership positions, or just plain genetic variation, some ancient humans absolutely could have carried significant extra weight. The biological hardware for obesity, that thrifty fat-hoarding machinery, has been sitting in the human genome for hundreds of thousands of years, patiently waiting for the software update that would finally let it run wild. And it wasn't coastal salmon runs or ancient chieftains that gave it that update. Not really, not at scale. It was agriculture and then, much more explosively, industrialization. When humans switched from hunting and gathering to farming roughly 10 to 12,000 years ago, everything changed. Suddenly, instead of chasing calories across a landscape, you could grow them in a fixed location, store them in granaries, and access them on demand. This was, on balance, a massive win for human population growth, allowing far more people to survive on far less land than ever before. But it came with some serious biological trade-offs, including, for the first time in human history, a meaningful and growing population of people with consistent enough access to starchy, calorie-dense grains to actually start putting on real weight. Skeletal evidence from early agricultural societies shows a whole cluster of new health problems that simply weren't common before, including a noticeable increase in dental decay from all that new starch and sugar, a general decrease in average height and bone density compared to earlier hunter-gatherer populations, and yes, increasing evidence of weight-related joint stress in certain individuals, particularly those higher up the social ladder. Then fast forward to the industrial and post-industrial world, and the floodgates don't just open, they get blown clean off their hinges. Suddenly you've got refined sugar, refined flour, industrial seed oils, and food engineered by actual scientists and flavor chemists to be maximally addictive, all available in unlimited quantities 24 hours a day, often for less money than the fresh vegetables sitting right next to them on the shelf. Remember that thrifty gene that evolved to help ancient humans survive famine by aggressively hoarding fat? That gene didn't go anywhere. It's still in you right now, doing its job exactly as designed, running the exact same subroutine it's been running for 250,000 years. The problem is that the famine it was built to survive never comes anymore, at least not for most people in developed countries, so that fat hoarding machinery just runs and runs and runs with absolutely nothing to counterbalance it. Your body thinks every trip to a fast food drive-thru is potentially the last meal before a famine, so it stores accordingly. Because as far as your 200,000-year-old genetic programming is concerned, it has literally no idea that the gas station down the street sells donuts around the clock, every single day, forever, rain or shine, war or peace. This is genuinely one of the most fascinating and honestly kind of tragic examples of what scientists call evolutionary mismatch. When a trait that was once a life saving advantage becomes a serious liability simply because the environment around it changed faster than evolution could possibly keep up. Evolution operates on a timescale of thousands of generations. The modern food environment showed up in roughly 2 generations. Your genes are still reading a survival manual written for a world that, for most of us, simply doesn't exist anymore. And no amount of willpower alone fully cancels out instructions that have been running quietly in the background since before recorded history began. So the next time someone shows you a cartoon of a lean, muscular caveman throwing a spear at a woolly mammoth, you can smugly inform them that the full picture is a lot messier and a lot more interesting than that. Most ancient humans probably were lean, yes, but not because their bodies hated fat. Quite the opposite. Their bodies loved fat, desperately, obsessively, and were incredibly good at making and keeping it whenever the opportunity arose. It's just that the opportunity almost never arose, at least not for very long and not for very many people. But when it did arise, whether through a bountiful coastline, elevated social status, or plain genetic luck, ancient bodies proved they were more than capable of carrying real, substantial weight. And there's a decent stack of archaeological, artistic, and skeletal evidence to back that up. In a strange way, every single person struggling with weight today isn't fighting against some kind of modern biological failure or personal weakness. They're fighting against a system that was engineered over hundreds of thousands of years to be almost impossibly good at exactly one job: keeping you alive during hard times. It just so happens that most of us, for the first time in the entire history of our species, are living through the easiest food environment our bodies have ever encountered. And that ancient survival machinery has absolutely no idea what to do with that sudden, overwhelming abundance. So, no, the caveman on the cave wall probably wasn't fat, but somewhere out there in some lucky river valley stuffed with fish, or sitting at the head of some ancient tribal fire pit with first pick of every single meal, there was probably at least one very well fed, very comfortable ancient human, proving that even hundreds of thousands of years ago, given the right circumstances, the human body was always ready to seize an opportunity, and it was never ever going to let it go without a fight.